Hi, my name is Daniel Beveridge. I'm Director in the Advanced Technologies Group within Office of CTO at VMware.
Hi, my name is Andrei, and I lead the Arm-based virtualization development work at VMware.
Today we're going to talk to you about our ARM-based solutions from VMware, spanning all the way from data center to edge. So in 2018, we unveiled our first reveal of ARM-based virtualization at VMworld. We talked about ESXi on 64-bit ARM, and we also hinted at the work we were doing on the Pi 3 to run ESXi. In 2019, we followed up with some additional reveals on the work we're doing on SmartNIC, and particularly the ability to run ESXi on some of the major SmartNICs from Mellanox, from Broadcom, even showed some embedded hypervisors running together for a blended hybrid system. In 2020, this year, we've revealed much more about our ARM-based strategy with the introduction of Project Monterey. Project Monterey brings much more sophisticated SmartNIC strategy that incorporates NSX and vSAN capability together with management and monitoring directly onto the SmartNIC. And these capabilities can be relevant both on-prem or in the cloud. Our goal with all of this is to build a unified platform for running VMs, containers, and even managing bare metal workloads. Our focus is on security, isolation, and scale, and to build technologies that are aligned with the new composable hardware running from data center, edge, and cloud. When we look at VMware's value, our focus is to bring our customers one infrastructure from cloud to edge. We want to create the important abstraction layers above infrastructure so that our customers have a unified experience. It's one vSphere with multiple CPU architectures, with the goal of embracing the full diversity of hardware that's out there, both in the data center and particularly at the edge, where we see that many devices are focused on ARM, and the ARM ecosystem is very key at the edge. Our goal is to be CPU and scale agnostic with our infrastructure, to have a common platform for workloads and security, and to be able to deploy workloads in a transparent manner using a common set of management tools across a wide range of devices, such as IoT gateways, SmartNIC accelerators, cloudlets, and various ARM-based storage devices, such as computational storage, vCPE and uCPE devices. So our goal as VMware is not solely to focus on one CPU platform or the other, but to bring our customers a unified platform that has common management capabilities and can essentially create the right abstractions so that customers can focus on workload management with the full security that will bring a common set of capabilities and robust security no matter what CPU platform they're working with. So where are we with 64-bit ARM virtualization? So in the past, we showed single host virtualization. Early models or early demos showed capabilities on a single hypervisor. But today we've got a full set of capabilities that integrates with vCenter, including some of the more sophisticated data center grade features we're known for, such as high availability, even vMotion, fault tolerance, and some more sophisticated capabilities such as software-defined storage or vSAN, and our NSX software-defined networking platform. We're able to run typical ARM-based distributions of Linux in virtual machines side by side and managed side by side with x86 virtual machines for a unified management experience. From a productization standpoint, Project Monterey is our go-forward strategy. Again, this is the ARM-based SmartNIC solution, which will allow us to extend vSphere's management capabilities across the data center, encompassing both virtualized workloads and bare metal workloads, bringing a common set of storage, management, and networking capabilities to the entire data center. On the exploration side, we continue to do work in far edge and near edge, data center and cloud, and we'll be talking some more about the far edge momentarily. So we've talked about VMware's core value, and I want to emphasize again that operational consistency is one of the key things that our customers ask us about. They want to embrace a world of ARM and x86 together, but they want to do it in a manner that brings operational consistency to the business. And as VMware, that's one of the key values we're bringing to the market in embracing ARM and bringing forward ARM-based solutions. Excuse me, is the single pane of glass stretching from on-premise, edge, and cloud, so that our customers have a common, consistent operational experience. One of the other areas that VMware can excel in bringing ARM-based solutions to the market is at the far edge, where resilient ARM workloads can take on a new relevance. VMware brings some technologies from the data center to the edge, such as high availability and fault tolerance. Now, traditionally, these were seen as exotic data center features, especially fault tolerance, which had potentially considered to have high overheads. But at the edge, density is not nearly as important as reliability. For far edge use cases that are in the critical path, the business needs to trust that the solution will stay up and running even across server failures. At the far edge in particular, there are typically very few or no IT personnel present to fix a server that goes down. So for the business to trust the edge with critical path workloads, we need to make sure that those workloads stay up and running. VMware brings some very unique technologies both with our shared storage, our high availability and clustering technology, and even in the highest extreme case, fault tolerance, where we actually replicate a virtual machine's running state between two servers, so that a server can go down and the virtual machine or the workload stays running transparently without missing a beat. This technology today doesn't exist at the edge, but with VMware's ability to run vSphere on ARM, we'll be introducing that high degree of resiliency at the edge that we believe will help accelerate edge adoption and help the business bring new critical path use cases to the edge. So, Andrei, would you like to talk about current state of ESXi on ARM?
One of the many questions that we get through the last few years of talking about ESXi and ARM is, of course, when is VMware going to make ESXi ARM available for evaluation? Wouldn't some kind of a public preview be a great idea? And of course, the reason for why we would want to entertain the idea of a public preview is to gather and understand the demand for ARM-based technologies with VMware in our existing markets and new markets such as Edge and IoT. So there'll be a target audience that would comprise, of course, of our customers, potentially new customers entirely, new market segments. And the question is, what hardware will we support, right? How expensive would this hardware be? How available would it be for others? Would this hardware be a good fit for the use cases that we are motivated by in exploring ARM virtualization and VMware? And so the fact of the matter is that over the last few years, ESXi ARM was developed on primarily server-grade ARM systems. And these systems are fairly expensive and low volume and hard to get. And again, this hardware really is about servers, not edge-oriented use cases that we were talking about in 2018 and 2019, and not even really developer-grade systems. So the experience, will be kind of challenging. You put this thing out there, but you couldn't run it on anything that would actually be important for us or that would show the differentiation factor of the technology in, say, virtualized edge compute. There's a driver story around that. If you would support a board, would you be able to extract the most amount of value from it by demonstrating support for built-in accelerators or onboard network controllers, things like that. And this takes us into a very important subject that standards are extremely important for ARM-based hardware, and especially even extending beyond just the server space. Now, ESXi ARM has been made possible in general by the adoption of standardized homogeneous standards by the ARM server ecosystem. So adoption of industry standards such as UEFI and ACPI mirroring what's been happening with the x86 ecosystem. And what this means is like on x86, you're able to have a single binary distribution of an operating system or hypervisor and run this on systems made by different OEMs with different CPUs from different silicon vendors and have a consistent experience and be able to run on every box, basically. Why are standards great? Well, they're all about customer choice. You're avoiding a vendor and platform lock-in. Non-standard systems provide less value for all the parties involved. They're not, sometimes they can be looked as a way of locking in the customer, but actually much frequently they lock out the customer. The customer is not going to move to a very strange and non-compliant platform that they might feel they'll be stuck with. And if you look at where ARM came from, and ARM came from this kind of embedded space, embedded space is a vertically integrated ecosystem, right? So mobile phones are a great example of that. So you have a chip from a silicon vendor that gets sold to a company like Motorola, which would then design the platform around it, or write the low-level firmware, port the operating system kernel. So basically, by the time you get the phone, everything there is completely custom. You cannot run a general-purpose OS on it. And servers, on the other hand, are the complete opposite of that, right? You can buy an ARM server from Gigabyte, and you can put Linux or ESXi or Windows or BSD on that. And then the folks who are developing the end solutions are different from the ones who are developing applications, OSs, bootloaders, and such. So basically, this enables kind of this wider market, to collaborate and cooperate with each other. Now, Edge really has been pretty much an embedded, vertically integrated market space. There was no common baseline for OS vendor support. You get a little embedded board like a Raspberry Pi, and you cannot run any OS on that. You can run the one that the vendor blesses. Okay, so this is actually a really big constraint, right? Because if you think about it, we've talked about over the years about the value of ARM and the edge. And one of the biggest values of ARM and the edge is the ability to create customized, specialized solutions and do this basically, in a way that has, basically good cost and, ability of differentiation. That was one of ARM's strengths. But when I hear, specialized and highly differentiated, I also hear a fairly low volume. So you need to be able to generate low volume solutions that are also low cost. Now, if you have to take up support for developing your own operating system to run your customized solution, it's no low cost anymore. So in fact, such platforms only make sense when they're trivial to support with standards. If you have to basically own the entire software stack, all the way from the bootloader, you've kind of violated the dream. If you consider that for edge-based solutions, long-term support is also very important. The system has to be operational in 5 years, 10 years time, which means it must be supported with off-the-shelf software. What if the vendor that you bought something from isn't around anymore in 10 years? Or what are you going to do? Right? That's not good. Okay, so this has been actually a recurring theme in our conversations and collaboration with ARM over the last few years. And we have actually worked with ARM and the Server Advisory Council to define this new set of standards called SystemReady and SystemReady Embedded Server as part of ARM's Project Cassini to go and solve this problem of missing standards on platforms that are not servers. Of course, Project Cassini is ARM's open collaborative standards-based initiative to basically provide a single software experience from cloud to edge. So, like I mentioned, ESXi ARM started on ARM servers, and this was basically grounded in the ServerReady certification and specs such as the server-based system architecture. That's the hardware spec. It guides how you combine ARM's different IP blocks, so how you generate your own IP blocks and integrate them in a way that's expected by the different OS vendors. You could basically say you build systems the way most of the server systems are built today in the market. That would be a pretty good way of looking at it. There are also firmware requirements. So the server-based boot requirements, SBBR, is the firmware side of that. And that again says, let's adopt the industry standards that exist on basically most of the servers out there, which are x86 servers, using UEFI, ACPI, SAMBIOS, because this is what the OEMs are comfortable with. That's what the OS vendors are comfortable with. And of course, there are certification requirements as well. These are the architectural compliance suites. So this is how you actually validate that the system is ServerReady compliant. So if it wasn't for that, ESXi and ARM would completely be impossible to do. But the next step from that is SystemReady. So SystemReady actually goes ahead and extends all three of these. I'll say on the hardware requirements side, what we've done is we factor out what we are calling the base system architecture, BSA. And this is common. This is common basically to both server and edge profiles. And the differences between platforms are now supplements, right? So there is a server supplement, and then would be supplements for other footprints as well. On the firmware side, we did something similar. There's now a common BBR, a basebook requirements spec, which is tailored to different scenarios. So there's a server boot scenario, which is exactly as BBR is today. There's a different lighter weight embedded boot requirements, which follows the previous EBBR spec. And there's even a new firmware requirement spec called LBBR, which is for using Linux boot, which is something some CSPs are interested in. And of course, the certification requirements have been extended as well to, of course, allow for all these different footprints and ensure compliance verification. Now, this SystemReady is what will give you ESXi ARM on the Raspberry Pis, on the SmartNICs, and all these other interesting form factors. Again, just to generalize, this is the SystemReady landscape is about having a one program on multiple bands. You know, VMware's position, this is very simple. We are interested in an open and horizontally integrated ecosystem solutions, driven by mutually compatible hardware and industry standards. We want multiple silicon merchants. We want multiple platform merchants. We want multiple OEMs. And as far as VMware is concerned, we're interested in SystemReady SR. That is the server specification side of SystemReady. It parallels the old ServerReady spec. And we're interested in the SystemReady ES, which is the embedded ServerReady, which is, again, you can think of it as a lighter weight server specification. So it still uses UEFI and ACPI. All right, Daniel, back to you.
Yeah, thanks, Andrei. That was a great information on the importance of standards in the evolution of this technology. So we are delighted this week at Arm DevSummit to release our ESXi on Arm Fling. We've been working on this for quite a while, and this is the first chance that we've given the community to actually get their hands on this technology. Flings are a program through Office of CTO at VMware that allows us to release technology to the community, give people a chance to kick the tires, check it out, talk to us about how they're using the technology, what use cases are important, and allow us to incorporate that feedback eventually back into the technology and as it moves along toward productization. So we're launching this technology. It's an as-is preview. It's not a beta or a product, and I want to emphasize that. But it is ESXi ready to go on ARM, and you can use it together with vCenter for some of those more advanced features that I spoke about, such as high availability, vMotion, and some of the other features you get through Virtual Center. It's based on the vSphere 7.0 code base, which is GA today. And we're giving the community 180 days to work with the technology. So it's a very long evaluation license, and it gives you a chance to really test out a variety of scenarios and get back in touch with us about what you like, what you don't like, and what are the use cases that are important to your business. So our goal is really to learn how you want to use this technology and to inform our decisions and thinking about how we want to carry it forward. So you can see there the links to the Fling site. Feel free to go check it out and sign up and download it. And there's also going to be more tips and tricks available at our blog website that you see there, blogs.vmware.com/arm. So go check that out as well for some great content. Andrei?
So let's dive into some of the platforms that we are going to support with the ESXi on Arm Fling. Now, again, just to mirror what Daniel was saying, I'll use support here in a very specific meaning because a Fling in general is not supported. But these are the platforms that we believe, highlight the value proposition of ARM-based hardware and with virtualization solutions with VMware. And the platforms are roughly divided into server and edge. On the server side, we believe that the best platform for evaluation will be the Ampere computing-based server platforms from Lenovo and Advantech. So everybody, of course, knows who Ampere Computing is. They are a CPU startup, pretty exciting company that they have both this Ampere eMAG platform released for a few years now, and they have an upcoming platform that they call the Ultra, which is pretty amazing performance. But with the Fling, we will support the eMAG. This is a pretty typical server platform. You get remote management, you get PCI Express, you can bring your own I/O, you're expected to stick your own network card into that. USB, SATA, it has, of course, support for NVMe as well. You can put up to 0.5 terabyte of RAM into it. And this is the platform that we'd like you to evaluate if you're interested in basically a traditional server role with ARM in your data center. The next platform that we support is an edge platform. So this is based on the NXP LX2160A chip, which has 16 Cortex-A72s. This whole platform really is, and this platform is a solid-run honeycomb. This whole platform really could be looked at as a microserver, or as a workstation, or as a network appliance, or as a beefy virtualized edge gateway. So there's some pretty amazing hardware on it. It supports ECC RAM. Of course, you can use SATA, NVMe, PCI Express devices such as another NIC, supporting up to 64 gigabytes of RAM, and this system is undergoing SystemReady ES certification. There's some minor limitations today. We don't support SD card. That's pretty slow, and we don't support the onboard networking. So you see those 4 SFP plus connectors on the board. That will be coming later, but it's not available today. Again, this is the kind of system that we believe could be actually part of a virtualized edge compute story. Going back to our demo with wind turbine or like an oil rigs, where you actually need to do some processing on data that you get from sensors, and it's a pretty powerful, beefy system. The next platform is also based on an NXP chip. It's based on the NXP Landscape 1046A. It is smaller. It has only 4 cores, clocked lower, but it still supports DCC RAM. It has 4 gigs of that. And it's another system that's undergoing SystemReady ES certification. That's still in progress. This is more of an industrial system, really. Whereas the other Landscape-based system is more of a microserver. This one is really meant for more kind of IoT gateway and industrial use cases. Both of these systems, by the way, they're available. You can go buy them. The NXP Freeway, or the 4-way, is available from the NXP site. The Honeycomb is available through Solidron site, and of course the Ampere systems are available from Ampere Advantech. And of course, and the most interesting side to this is, Daniel, will you cover this?
Yeah, last but not least, we're delighted to bring support for the Raspberry Pi 4 to the Fling. We've worked very hard to get this working in partnership with ARM. We've built a special firmware, UEFI, that will work to boot ESX on the Raspberry Pi, and that's in part because of the standards work that we've been doing together with ARM that Andrei mentioned earlier. In addition, we've also built a custom NIC driver for the onboard Ethernet NIC. So that's supported out of the box in the distro that you can download. We support 4 gig and 8 gig models, but we highly recommend you consider getting the 8 gig model because you have a lot more working memory once you load ESX. I think it's something like 2.5 gigs versus 6.5 gigs of working memory. So definitely worth it to go for the 8 gig model. This is SystemReady ES certified, and we also have support for the USB 3 ports on the Raspberry Pi. So you can use them for a range of things, including an additional NIC using the USB NIC and other USB devices you may want to make available. So the way this will be installed is you will load a UEFI firmware onto the SD card and boot up from that, and actually do the install on a USB storage device that you can acquire separately. So this is going to be exciting. It's going to open up a whole new world of possibilities. Here's basically a $75 server that you can use to do a wide range of far edge activities and use cases. It integrates with Virtual Center. We've been doing things in the lab like running vMotions between Raspberry Pis and other types of features that you would associate with data center servers. We're now bringing those directly to the Raspberry Pi 4. So very excited to see what the community wants to do with this and the kinds of use cases that people will talk to us about. So this is a great day for the Raspberry Pi community and for anyone really interested in far edge computing. Andrei?
Okay, yeah. So this is a great time to talk about the different collaborations that between VMware and Arm that led to this Fling. As Daniel pointed out, the support for the Raspberry Pi was actually a pretty long journey. So it started as an official collaboration at the Arm partner meeting last year, where we proposed this notion that the Raspberry Pi 4 is standard enough, potentially, where you could imagine that it would be supporting a subset of those server-ready specifications. And this led to this creation of an open source community project behind the Raspberry Pi 4 UEFI. It's now owned by the community. VMware and Arm are just two of the many contributors to this. Anybody can go and build this, and it's actually a part of this open source UEFI implementation called Tino that's up there, and it's one of the many Arm platforms today supported by Tino EDK2 platforms. And this firmware is not ESXi specific. It's actually a way that today you can boot Linux, NetBSD, OpenBSD, and even Windows 10 on the Raspberry Pi. So this has been actually a pretty massive collaboration that, it was based on an earlier efforts we did around the Raspberry Pi 3 firmware. But it's not just collaborating on the firmware. The Raspberry Pi 4 is literally the first system-ready certified platform in the world. It actually kickstarted this entire notion that server-ready wasn't enough, that you needed this other more encompassing set of standards and certifications. So that's been pretty exciting for us. We've been also collaborating jointly with Arm and NXP on validating their UEFI and ACPI firmware for the two Layerscape platforms. Of course, the chip in the Honeycomb, and of course the smaller chip in the Freeway board. And all of these collaborations are done either as part of Arm's Project Cassini, which is about bringing standards to edge, or as part of the ServerReady and System-Ready working groups.
And in the last case, I was just going to say, in the last case with the Raspberry Pi 4 Genet driver for ESXi on ARM, we partnered with ARM directly together with our XLabs program and Office of CTO to actually work closely and build a driver for ESX that would work on the Raspberry Pi 4 specifically to support the Fling. So it's a great example of collaboration and partnership with ARM that we intend to continue. Andrei, you want to tell us a little more about Monterey on close?
First of all, I would say, call to action: go check out the Fling, right? Share your exciting use cases with us. The links we already mentioned before. Go to the blogs. There'll be some articles posted by our team members about how to get things going. maybe some unsupported use cases or unsupported platforms even. And then, of course, you've heard about Project Monterey. Again, if you want to find out more, please join us in our booth, right? We have an official booth at the DevSummit. Please join us and we can talk about the Fling. We can talk about Project Monterey. We look forward to talking to you.
Thank you, everyone.